So, while we get set up on the slides here, my name is Roman Spitzbart. I work for Dynatrace as a solution director covering Europe, Middle East, and Africa. And I'm really proud to be at the easternmost part of what is part of my region. It goes quite a bit south, but this is literally the easternmost of the countries that I can actively cover. What I want to talk to you about today is less about tooling, less about what we do as a software vendor. I want to walk you more through how Dynatrace has changed over the last couple of years and really went from a very traditional, almost waterfall-oriented software developer into a fully agile, DevOps-driven process. So, when we say DevOps, in reality, actually, we operate based on a no-ops principle. What that means is we have no operation staff. There is nobody on call, there is nobody available 24/7 for running our software platform. That does not mean we don't have someone who's responsible for our operations team. So don't differentiate between operations and nobody's responsible. In our case, that's right now around 7 people, and what they manage is a SaaS deployment that hosts around 5,000 active customers. It is around 20 clusters, all AWS-based. And we also manage a large number of clusters that our customers deploy in their own data centers. So when we talk about no-ops, to break those numbers a little bit down further, they manage around 1,000 instances in AWS. 1,000 individual classical servers are under their responsibility. On their platform, they have around 5,000 deployments per day. Why 5,000? Because every time one of our customers deploys our software, well, that's also deployment event. Somebody does something somewhere that could potentially go wrong, and we need to make sure it doesn't go wrong and that we maintain the availability stats that we have been over the last, well, in this case, more than 2 years. What this transformation also meant was a very, very fundamental one for us as a software vendor. We went from 2 releases per year to 26 releases per year. So every 2 weeks, we push out a new feature release. And the other radical change that happened for us as part of that transformation is that where before every single production bug was found by our customers. Now 93% of our production issues are found by our teams before a customer even realizes we have a problem that they could have ran into. Let's also be very clear, yes, I'm part of a technology vendor, but the change to DevOps for us was only about 20% about technologies. The largest part was about a cultural change, about a change in mindset that needed to happen throughout the whole organization. It wasn't we add a DevOps team and suddenly we are a DevOps organization. And what for us proved very valuable to say, if you want to talk about a cultural change like that, try breaking it down for somebody who's not technical. I try explaining it to my wife or to my parents on what is it that we do when we talk about DevOps. And the story that worked best for me is to talk about photography. Most people in the room are old enough to remember the times when taking pictures meant you bought a film that you put into a camera, or you bought one of the disposable cameras that had the film built in. You took your pictures, then you shipped them. So you had literally 24 features that you shipped them together. Of course, there was some quality control. Whoever developed your pictures made sure that they have the right amount of brightness and all those kind of things. And then they got shipped to you, to the customer, and that's the first time you got feedback. That's the first time, I'm sure we all had example that late feedback sucks. And on pictures that you took on your vacation, it sucks even more because there is no way to do them over. There is no way to say, well, in 2 months we're going to do it differently, we're going to do it better. So there's a lot of frustration that comes out of a process like this where you don't have a direct feedback loop. Now, think that over how photography works today. If you take pictures with your phone or with your camera, if you still have one, you immediately get feedback. Not only do you see the picture, you make the first adjustments before even saving, before even publishing. And after the optimization, you can get very direct feedback. Everyone knows if you post a picture to a social platform, be it Instagram, Facebook, Twitter, whatever it is, you very immediately will get feedback what other people think about your pictures. And changing this loop is really what DevOps is all about. And the reason why I put this slide here specifically up, because I don't like the term DevOps. DevOps misses one critical important piece, and that is the business. We're not doing DevOps for just the DevOps purposes. So business DevOps is really what we're all about. It's about the integration of development, operations, but making sure that business gets a benefit. We're not doing DevOps. We didn't start DevOps because we felt two weekly release cycles are better than 6 months. We did it because we want to deliver features faster. Faster features means we are more competitive, we are easier differentiated against our competition. That's the reason for doing that. So let's, when we talk about DevOps and the migration there, let's never forget, why are you doing it? What's the actual goal that you are going for? So let's now translate this a little bit into what does this mean, or did this mean for Dynatrace? So I joined Dynatrace in around 2010, so roughly around 2011, we literally ran like clockwork. Every 6 months, we deployed a new release, which meant we developed for about 4 months, we had a testing period, we then fixed stuff until we got to a point where we then shipped this to a customer and they deployed it onto their production system. Today, 2018, as I mentioned before, 26 feature releases per year. Important difference. 26 times we deliver new functionality to our customers, not just bug fixes, not just small things, but really fully feature releases. I mentioned before the number of deployments, and combining that with software that runs both in our data center, we offer as a software as a service, but it also runs in our customers' data centers. If they, for example, for regulatory reasons, don't want to share their data into a cloud vendor, but they want to keep it in their own data centers. Now, this change initially was something that I can guarantee you 90% of the organization believed to be a mission impossible. When our CTO first stood there and said, I want to get to a system where we can deploy into production in less than 1 hour between a developer making a change and the change being live in production, a large number of people called him crazy. Nevertheless, the state we are right out, it takes us about 53 minutes from a check-in into a production deployment with quality checks. That's not just we manage to build, compile it, and ship something, but there is a basic level of checks that happen in case we need that rapid deployment. We know we develop business-critical software. We can't wait to fix an issue sometimes in 2 or 4 weeks. Sometimes we need that rapid change and that possibility. Now, our journey into DevOps really started for us with a very key hire. The woman in our case, who now leads our DevOps team, was a very, very important change catalyst. Now, I'm not saying everyone needs to now hire somebody who knows DevOps and who has the vision of DevOps. I know there is enough organizations that can help you on that journey also externally without hiring somebody full-time. But for us, in hindsight, this was really, really critical, and it was, fortunately, a hire we got right. Because getting the wrong person to run a DevOps team could have derailed this whole change pretty quickly. So what does our DevOps team now do? I mentioned before, they're not really operating the platform. So what our DevOps team really, what their mission statement is, that they are responsible for giving engineers visibility into what's happening with the stuff they develop, to give engineers control over how they want to deploy changes and fixes. I'll get a little bit later on to why it is important that engineers and the engineering teams do have that power in our system. And last but not least, also make sure that the engineers can really take ownership, not just of the software they build, but literally the whole deployment lifecycle. If this change gets deployed into production, the engineer decides how it is done. Is it a rolling update? Do we need a downtime of certain issues? There's nobody else who decides for them what they need to do or how they need to do that. Our DevOps team is, I would say, a mixture of, on the one hand, they are an engineering team in the sense they develop certain tooling for our teams to use. Toolings like visualizations, they develop toolings like how can I get easily access to log data from production systems and things like that. But on the other hand, they're also really the team that manages production. They're the team that makes sure that we do things not just right one time, but we do them right consistently, and that we do them in a controlled fashion. And that an engineering team who sometimes gets a little bit overexcited, there is a final stop that says, hey, back to the drawing board. I know you think it's the greatest change ever, but let's look at this in the larger picture rather than just isolated teams. So, for our feature teams, for the teams that really develop functionality, this means they have a lot more responsibility than they used to do previously. What I listed here in green are typically things, we already did them in 2011 under the term of continuous integration. Those teams were responsible, well, obviously for developing the features. They were also responsible for automated testing, building tests, making sure test coverage was enough. What got added to them was the part that is in purple and below. Everything from taking feedback from production to improve, to harden their code, making sure that they run into less issues, to using the proper feedback channels when necessary, all the way to making sure that they have migration plans. It's not enough to say, I developed something, it compiled, it was tested, now somebody else needs to take care of it so that it gets into production. And what I now want to break this down is in a couple of use cases, and I'll go into a little bit more details on some of those use cases. So for us, what was the major steps of this journey? Well, first of all, our architects are responsible for production. And the reason why our architects are responsible for production means that if something happens at 2 a.m. where our clusters run into a major issue, the second phone that actually rings is the one from our chief software architect. And I can't over-describe how much that has changed the approach to what is considered production readiness. Once they realize that it's not somebody else suffering, but once they realize that it is on them when something goes wrong, they suddenly look at things a lot more closely. They think a lot more about, yeah, but how do we deploy that in production? How will that work if this feature is not used by 10 users, but by 20,000 users? Am I still comfortable? Am I still, as an architect, saying, yeah, sure, we'll deploy it into production, no worries, everything will go great? Yeah, I can guarantee you they now think twice. And it has really led to a different approach of, they pay attention to stuff like that a lot earlier because they know at the end they'll be the one who are responsible for it. The second part that was for us pretty important is automation around infrastructure. The reason why we run our SaaS platform in AWS is not because AWS is cheaper, it's not because we like Amazon a lot more than we do with any of the other vendors, it is the flexibility and the speed of deployment it gives for us. When we first started deploying our platform, we had the plan of deploying it into our own data centers. Dynatrace has a long history. We had data centers, we had servers, and the first time we started talking about, well, we have this new product, we want to deploy it into a platform, the initial response was, yeah, we need about 3 months of lead time. We need to purchase a server, it needs to get put into a rack, we need to network cable, we need to install operating software, we have certain standards, we need a change window to do all of that. I can guarantee you that 3 months lead time doesn't really work well if you have 2 weekly release cycles. So for us, the fact that, in this case with Amazon, we have full automation of everything. Setting up a cluster involves no manual steps, because AWS gives us the API to spin up the infrastructure. We can then provide the tooling and scripts to deploy our own software and to really stand up and configure an environment completely on its own. The next steps. The same deployment in every stage. Whether something gets deployed into development, test, or production, there is no difference in the automation we use, because that again means if something's wrong with the automation, we learn about it in development and we don't learn about it at the end of the build pipeline when we go into production. The same monitoring tool for every stage. I want to make sure that my developers find issues with the same clarity, with the same level of detail in production, in test, and in development. Again, I don't want to wait until something hits in production before they can start working on it. Then, the direct feedback. One of the key things that I mentioned before, and I'm going to mention it again, our DevOps team works for the engineers. Their primary customer are the engineers to provide them good feedback so that they can do their job more efficiently. Control into engineers' hand, again, wherever it makes sense. We still have a final go, no-go decision that is not part of the engineers team, but there is somebody centrally, as I said, the architects, for example, have a hand in that that makes the ultimate deployment choice, but put as much as possible of that into the engineer's hands. DevOps means that developers need to think as operations, and if I don't give them control, how can I ever expect them to take that seriously if they're like, yeah, you kind of ask me, but then you overrule me anyways if what I tell you is not what you wanted to hear from me. That's not how DevOps works. And then the last point on my list, a fast lane for production. I mentioned this before, yes, the DevOps process with the 2 weekly cycles means we are pretty agile, but it still means between change and production deployment, there's 4 weeks. There's 2 weeks in a deployment, in the development environment, there's 2 weeks in a test environment, then changes get deployed into production. Sometimes there are fixes that can't wait. Sometimes there are changes that need to go into production straight away. And being able to still have that flexibility is one very important part. So let me spend the next 20 minutes I have left to dive a little bit deeper into some of those points to give you a little bit more context on what we mean with them. And I'm going to skip the first two because I think they're pretty self-explanatory. But the third one, the same deployment, automation across the whole pipeline. A pretty important step because, as I said before, not only do we want to make sure we find things as early as possible, for us deployment automation actually means that we have a separate feature team that just works on orchestration. They literally build the tools that you see here, the 2 screenshots you see here are internal tools. They just build for managing our SaaS platform, for automating, for which changes, which fixes get deployed where, who's authorized them, keeping an audit log, when was something done, and really making sure that, again, we have that feature set available for the engineers to use. And it is an ever-changing feature set. It is not something that it's not built just by ourselves. Obviously, there's a lot of common tools. For example, we use Ansible Tower underneath. We use Puppet for some of the automation steps. So don't take this as we build everything from the ground up, but we made sure we have a solution that's really tailored to our needs, to what we, Dynatrace, need for running our platform efficiently. The same monitoring in every stage. Well, obviously, we are a monitoring software company, so depending on how you want to see it, either we drink our own champagne or we eat our own dog food. So obviously, we want to make sure that we use our own monitoring tooling, not just in production, but provide the same feature set across the whole pipeline, A, because it gives better quality insight, and B, because it also means that we already learn in development how we need to adjust our monitoring. Sometimes new features require a new dashboard, or they require a change to say, you know what, it would be great if we see this or that. I want to learn about it in the orange part, which is 4 weeks before we hit production, so that I have time to adjust and make sure that things are set up the right way. So, direct feedback. One lesson we learned that feedback from such an automated process to an engineer is only valuable if it is very, very rapid. And very rapid for us means 10 to 15 minutes. Anything longer than that, and the engineer will have moved on. He'll have something else. I might just remember back. Do you remember which email you wrote yesterday around lunchtime? And if I now send you a blank feedback and said that statement was wrong, would you know on top of your head, ah, yeah, that's exactly that one email? Well, guess what? Engineers are not different. They probably don't know in full detail what they've done yesterday around lunchtime. So the closer you can provide them that feedback, the easier it is for them to work, to adjust, and to use that feedback to really make those changes and adjustments. Feedback for us also means we try to find unconventional ways of how we present that feedback to our engineers. Of course, an email is still a method where you can provide a lot of context, a lot of data, but one of the feedback mechanisms we use, and you can see it a little bit in the middle above the head of the nice guy in the white suit here, is we call it a UFO because it looks a little bit like an unidentified flying object. It hangs from the ceiling. What it literally does is it visualizes build states. On top, if the top ring is red, that means somebody broke our trunk. Whatever we have in trunk currently does not work anymore in the sense of automated tests are broken. I want to make sure that a device like this, in our case, it hangs in the cafeteria. I don't want to see an engineer sitting there having coffee, enjoying his lunch while he just broke the build with his last check-in. I want to foster those communications, those conversations on, hey, do you see this damn thing is red for the last 3 days? What's going on here? Are we not able to build something for the last 3 days, or has it been broken so many times that it looks like it's always red every single time I get coffee? So feedback like this, visualization, really constantly putting this in the forefront of what people think about is important. And if you're interested in using that specific gadget, there is the link, dynatrace.com/UFO. You can either get one from us or you can 3D print it yourself, because as everything, if engineers build something, there will be 3D printing, there's a custom software behind it. It's a nice side project. Automated feedback for us also meant we took full advantage of the fact that engineers are very often lazy. At least the engineers I work with are. Give them a task that is very repetitive, very manual. I can guarantee you by the third time they're doing it, they have started thinking about how can I automate this? I don't want to keep checking the same 5 values every time we do a build. Why can't somebody do this automatically for me? And in this specific example, what that meant is that this developer started to put the expectation into the deployment code. To say, you know what, if this test runs, I expect a certain behavior. And when this, what he then called a performance signature, gets violated, when suddenly the response time is a lot higher than it used to be, again, automated feedback. No longer somebody needs to manually look at, okay, does this or that feature now work differently? No, it's automated, and being part of the deployment script means if he adds new functionality, he will adjust the threshold. Sometimes things get slower. You add new functionality, you add new features. It's normal, it's expected. Being able to do that as part of the deployment script, again, saves a lot of time and makes the feedback a lot more automated, a lot more valuable. Control, giving engineers control. I mentioned this point already before. What this helped us to get away from, and yes, we had that culture before, I'm not going to lie about that, about engineers, well, it worked in my environment. Look, I've showed you the feature, it clearly worked in my environment, so it's not my problem, it must be somebody else's problem, without being very specific whose problem it is. But it really helped getting away from, first of all, saying a feature doesn't need to work in your environment. If you want to have a feature being signed off as, yes, it's complete, or a story being completed, you need to show that in a fully integrated sprint environment. Only when it works there and when you can show it to a product manager in that environment, then do we consider it really complete, because that means it's part of the automation, it is something we can reliably use and deploy going forward. And works in production is really the result of that mindset change. Engineers no longer think about, well, it needs to just work in sprint, but they really now think about, okay, whatever I do, I need to make sure it also works in production, because thanks to the feedback loops and the automated feedback I talked about, if it doesn't, it's going to hit myself pretty quickly. Or it's going to hit my architect, which isn't the nicest of all conversations if you have the architect who woke up at 2 a.m. explaining to you why you did a bad job and not delivered the functionality in the quality he expected it to. Now, I also mentioned this fast lane, and I mentioned it now 2 times, I'm happily mentioning it the 3rd time, because it is for us, that was one of the learnings we totally did not expect. When we started with our approach, we are like, well, we're going to do everything in 2 weeks. For us, 2 weeks sounded like hyperspeed. Other than 6 months, well, imagine, within 2 weeks we can get something in production. Well, within 2 weeks means for us we have a development stage, so every change lives for 2 weeks in a development stage, it gets promoted into, in our case we call it an acceptance stage, and then again after 2 weeks we start deploying into production. If you develop mission critical software, there are changes that can't wait that long. Specifically bug fixes. And hot fixing doesn't necessarily mean we bypass all those things, but we only do a very selected subset. And hot fixing is exactly one of those things where if you want to go down this route of a hot fix that gets built, runs through some basic testing, but then gets straight away deployed into production, that's a level of control that we don't give the individual engineers. That is something that is centrally done by one of our 3 development leads that can make a decision like that to say, is the change important enough that we really need to take this fast lane? Or is it something where we can say, you know what, we have a workaround in production, let's do things properly and let's go through our normal cycle in that case. But for us, a very important adjustment of the 2-weekly process was having this fast lane for being able to deploy into production, especially since we deploy SaaS software, which means we really sometimes need to fix things centrally that affect thousands of customers. Now, everything I talked about up to now are things that we have already done. That's the status quo for where Dynatrace currently is. I want to spend the next 10 minutes or less talking now a little bit about where's the road continuing for us. What are some of the things that we are now working on getting into our environments and getting built in? And one part that becomes for us more and more important is we want to start leveraging some of the feedback a lot more intelligently. Rather than just taking the tickets you see here at the left side where, yes, we found a problem, something on our side, on our SaaS platform goes wrong, we also want to leverage the insight that Dynatrace, our monitoring software, can give us, the root cause analysis it can give us, the detailed and linked data across different systems. Because very often, with that level of feedback, we can pinpoint the issue a lot quicker. We don't spend as much time diagnosing. We don't spend as much time looking at dashboards, trying to understand what's happening, and to really leverage machine learning a lot more for that purpose. And where we are now working on is the next step. It is auto-remediation. It's building a self-healing platform. It's taking the automation we talked about now to the next level. Not just providing feedback, again, to a human who then decides what to do, how to leverage it, and what to do with the data points, but to first of all take this initial data, yes, flag it up. In our case, one of the key things we use is Slack internally, so making sure, hey, we just found a problem in production, somebody should be aware that this is going on, but then leverage the deeper data that we have beyond a customer has a problem to automate some of those steps. Because what we looked at is, and what we realized is, a lot of the runbooks we had are really, really basic. Runbooks like, if something happens, this component, shut it down, restart it. Do we really need a human to look at that component, issue that command, and start it again, and then take a look what's different? I argue that that is something we can and we are in the process of automating. Automating steps like, if the CPU is exhausted, well, we have an agile platform at another instance, mitigate the impact. Microservice architectures have the large advantage that if a single or multiple instances are overloaded, you can add more capacity to the system. Or if a connection pool gets exhausted, we use some databases behind the scenes. Well, guess what? The human probably as a first step will try to expand that connection pool to again make the problem go away while he diagnoses the issue and tries to find a more permanent fix. Or if this is caused by a canary release we just put into production, well, guess what? Switch back to the previous one. Obviously, your canary just failed. It just died. It fell off in the cage. Go back to the previous one. Automate it, not a human that says, oh, I see, whatever we deployed had a problem. We need to change. And if the impact's mitigated, make sure the teams know, make sure that the fire drill's called off, make sure that the operations team is no longer in red alert mode, but make sure that they know, yes, the problem is mitigated. This does not mean the problem is fixed. Somebody will still do the diagnosis and still will try to make sure it doesn't happen again, but it's on a completely different speed and urgency than when the problem still occurs and still happens for customers. Or, well, in case if it is still ongoing, then start escalating. That's when the alerts go out to ServiceNow, to PagerDuty, or whatever systems you use for incident management, for alerting, for handling all those processes behind the scenes. But first of all, when something now gets to the red part at the bottom, it means it is a lot more qualified. The human will know immediately, well, I don't need to try steps 1, 2, and 3 because that's what the automation's already taken over. I'm going to focus on finding and digging into the issue. And in our case, when we did an analysis, we found in our case around 2/3 of the problem are something we think we are able to automate. 1/3 will still require human intervention. But 2/3 can at least be mitigated, fully automated, meaning again, more stability in the platform, in the longer run, less people are needed to run, or as in our case, the people that used to do this can now focus on other stuff. We have enough things to do. It's not that we need to lay them off or we need to fire them. We have enough other things that they can be much more productive than keeping a platform alive by diagnosing issues and trying to find them. So, where Dynatrace started, 2011, was 6 monthly release cycle, everything on-prem, waterfalls with 10 sprints, with fixing periods, with testing. Where we are today is we are in a fully driven DevOps development cycle. Every 2 weeks, we do deliver new functionality. To be honest, the 2 weeks is not completely true because around Christmas, we usually have one period where we have 4 weeks, simply because we know a lot of our engineers will be away between Christmas and New Year's, so we give them a little bit longer time during that period. But nevertheless, on principle, it still is every 2 weeks. We have invested a lot into the processes. We have a separate DevOps team that just focuses on providing engineers the right tooling. We have a separate team that just develops the orchestration tools we need for developing and for automating all those things behind the scenes. Partly because we develop a pretty special kind of software. We monitor your software, we develop agents, we develop sometimes stuff that is very critical and can have a large impact if it goes wrong. So yes, we needed some specialized tooling in order to make sure, for example, that automated tests are possible in that area. But partially also to make sure that we really can fully automate from check-in all the way to setting up clusters this development cycle. And where the journey for us now continues and where for us the next goals are is self-driving IT. It is the autonomous cloud. It is the environment that is by itself diagnosing issues, finding issues, and is resolving most of them automatically. So taking the DevOps principle one step further, not only do I want to make sure that teams work together, not only do I want to make sure that I'm getting more agile, I also want to make sure that if problems occur, the system is as self-healing as it possibly can. Again, because the end goal for us is a stable platform that we can innovate quickly for our customers, for the users of our monitoring software. And I'm looking forward to talk a little bit more in the afternoon what this software that I talked now a lot about, how we develop it, how we build it, what Dynatrace is actually able to do for you. Thanks for listening.